Let's talk about how to calculate these two parameters, mu and sigma. I will use the same example with the chloride content in water, but in this case, I will assume that this is the population. So it's not a sample, it's a population. And the size of the population is 10. Okay. Well, the first is mu. Mu is an average or mean or average. And you can calculate mu as follows. You can just take the first value and add the second value, add the third value, and so on and so forth until you reach the last one. Then just divide to the total number of values. So that's how to calculate mu. Okay. You can write it mathematically a little bit shorter. We use sigma if we want to sum up several values. Then you have index of values. You start from the first and you add with the last, x capital N. Then you just use I as an index here and divide it to n. So it means that take x1 plus x2 plus x3 up to xn, take a sum of all these values and divide to n. So this is how to calculate mean or average. Okay. Now how to calculate sigma. Well, to calculate sigma, we have to calculate first the sigma squared, the squared value of sigma, which is called a variance. Variance. Okay. The variance is a measure of spread, how far your values can go from the average. Strictly speaking, variance, it's just an average squared distance from all your values to the center, to the average. Okay, let me show you this. So how far, for example, x1 from the average, how far x1 is from mu, we just need to take a difference, right? So this is the distance between x1 and mu, but it can be negative if x1 is smaller than mu, so we just square it, because we are interested only in absolute distance, not in is it negative or positive, okay? Then we do the same for x2, so just how far x2 is from mu, we just take a difference and then square it. And then we just continue for all values till we reach the last one. Xn is minus mu squared. Then because we want to get an average squared distance, to get an average, you remember we just need to divide to the number of values. So this is how to calculate the variance. Again, we can write it in a shorter form using this big sigma sign. So it's a sum. I goes from 1 to capital N. Then we have xi minus mu squared divided to the n. So this is the variance. Okay. And then you can calculate a standard deviation by just taking a square root of the variance. Okay. So this is the sigma is a standard deviation. Standard deviation. Okay, so let me show you some example. Let's take these values. So this is my x value. So this is the concentration in milligrams per liter. So we have, for example, 50 here, 60 here, 70 here, and 80 here. We have the middle points, 55, 65, 75, and somewhere here it's 85. Okay. Now the values, we have 53, we have 81.5, we have 66.5, somewhere here. We have 61.4, we have 66.4, very close to 66.5. Then we have 60.4.5, sorry. Then we have 61, somewhere here. Okay. Then we have 71.5 and 2 times 71. So we have two values here. I'll just make it the bold. Okay. So if we sum up all the values, so if we take a sum of all values x, xi, I is from 1 to n, you can just check it with calculator. We will get 663.8. 663.8. Okay. So it means that the average, you can calculate the average mu by just taking 663.8 and divide it to 10, which is our capital N, which gives you approximately 66.4. Okay, so this is where you have the average. So 66.4. This is mu. This is mu. Okay. Now how to calculate the variance? Well, we take the first value, so that's the first value, x1. Okay, this is mu. Then we take a distance, so this is a distance between the first value and the mu. I'll call it d1. Okay. Then what we need to do is to square it. So I'll just write it here sigma squared equal to d1 squared. Okay. Then you take the second value. So let's say this is the second value, x2. You take a distance, how far the second value is from the mu. So this is the second distance. Then you add the squared second distance to the previous one squared. Then you continue for all the points until you reach the last one, dn squared, and then you divide it to n. So you can see that indeed the variance, the sigma squared, is just average squared distance from every value to the average, from every value to the center of your distribution.